Welcome, everybody, to the American Space Museum. I'm Marquette, and I'm so glad you're with us today to stay curious. Beside me is Steve Agid.
Oh,
Steve, welcome.
Okay, nice to see you again, Mark.
Agid, I mean, not, I said Agid like Agid.
There you go.
Agid, like Agid. Steve Agid there.
There you go.
Steve, I've known you for a couple years. 2 years ago, you were with Bart Martindale's pinch hitting for me. We can't believe Stay Curious has lasted another 2 years, and I can't believe that you're on the program with me. You're a person I admire. He's a wonderful communicator out there at the Kennedy Space Center Visitors Complex, and his story today is going to be about the 50-year anniversary of Skylab. Steve, welcome.
Well, thank you very much, Mark. Pleasure to be here. It's a pleasure to spend some time here in the museum going through all the different artifacts you have. It's a great museum, and you can get up close and personal with a lot of different hardware, something you can't do at a lot of other museums where everything's behind some kind of barrier or rope. Here you can get up close and personal, really inspect the hardware.
Well, how many years, tell us a little bit, thank you, number one, and before I get into where you grew up and how you got into space, because this man's a very knowledgeable person. Let's say if I have a gallon of knowledge myself, and I think I know a lot, he's got one of them tanker trucks that the gas station pulls up and fills up. That's what you've got compared to my little gallon there. And it's very impressive, but you've got an articulate way of delivering it, and you're never condescending. And I think that's very important about people that know a lot about something, is you've heard many questions numerous times, and yet you always deliver it like it's the first time you've heard it.
Well, there's an old expression that says something like, people don't care how much you know till they know how much you care. You can't be condescending to people. You have to explain things. And one of the things we're trained to do, explain things on people's level. First question I might get might be from a kindergarten student. Next question might be from a Nobel Prize winner. I'll answer the same question two completely different ways.
Great point there. Contrasting our humble museum that's been around 20-some years, preserving the birth of America's space age in what we call its delivery room here in Brevard County. People go to the Kennedy Visitors Complex and have a great time, and then they come here, and we know that they like the intimacy here. And it's comparing apples and oranges, but put that together for us for people that have never been to both.
Okay. That's a great question. The reason I'm going to answer it this way is it's very, very important. We have a lot of the big hardware out there. We have a real life-size Saturn V rocket, 363 feet long. This building isn't 363 feet
No.
long. There's certain things you can't have. The Smithsonian, the National Air and Space Museum at the Smithsonian, it's sometimes called America's Attic because everything goes there. But not everything can be displayed. What do you do with those priceless artifacts that can't be displayed? Well, they're locked away somewhere.
Yeah.
What do? You put them here.
Yeah.
Okay? You can't fit a moon rocket in here. You can fit other things in here. So there's so many items on display here you won't see at the visitor complex. We have so many more bigger items.
Yeah.
Okay, but a lot of those other intimate items you can see here.
Well, we have manuals. We're all about the space workers. I challenge you to find another Block 1 emergency egress manual that's nearly priceless that we have here. We have a lot of artifacts that I tell people every day. Our VAB model is just not a cool-looking model of VAB. It's what they used in 1960 in the wind tunnel test before they built the doggone thing.
Well, yeah, you just mentioned a second ago, just for the viewers, you said a Block 1 egress model. And for many of you out there, might not make much sense. Well, the Apollo spacecraft, there were two designs. The first was Block 1. That was used for the Apollo 1 mission. Unfortunately, the Apollo 1 mission, there was a fire, the crew was killed. They decided to no longer have a Block 1 spacecraft. Since there was going to be a delay of about 20 months, why don't we go straight to the Block 2? What was the difference? Well, Block 1 was just going to test that spacecraft in Earth orbit. It wasn't going to be going to the moon. We don't need a docking system. There's a lot of things we didn't need. You have a manual for how the crew should escape from the vehicle. The manual that should have been used or could have been used the day that the crew was killed. So to have something knowing the background behind some of the things. And when you come here to the museum, it's not a dead museum where you just read the placard. The people that are going to be taking you around are the people that worked these programs. So that's very important.
Great point there, Steve Agid. And one of those people is Marty Winkle, one of our what we call national treasures, a man that worked on the lunar module for Grumman and then worked for on those space shuttle main engines. Marty Winkle, good to see you, Marty. We're thrilled to have Steve here today. I know you've seen him escort people around the property out there time and time again. And do you have anything to say? You want to say hi, Marty, on our USAC family microphone there?
Hi, Marty.
Good.
That's just what you asked me to do.
Wanted to warm him up there. Okay, great. Well, Steve, tell us a little bit about where you grew up and how did you get involved in this? And then we're going to start right into talking about the 50th anniversary of this wonderful space station behind us.
Well, the first childhood memory I have is when my dad told me about the launch of this thing called Sputnik.
Ah.
That was October 4th, 1957. The next morning was a Saturday, and I wasn't very impressed, which surprised my dad. And the reason for that was I watched a lot of the space shows on TV. And I responded, having something circle the Earth is just not that impressive when Commander Cody and some of the other folks have gone to different planets, and it's like, what's the big deal? And then he said, Stephen, this isn't for TV. This is for real. And I just can't imagine, what he thought when I just looked up at him, that we were really doing the space thing.
Uh-huh.
And that was back in 1957. And
You weren't too old then. We're contemporaries.
I was just 5.
Yeah, okay.
And then I went to school down here at Florida Tech and graduated there in 1974. Became a spacecraft flight controller and spacecraft analyst for the RCA company for 12 years. Then I worked 14 years on the space shuttle program, and then another 14 years on the Atlas and Delta program. I did the retirement thing for 12 days, didn't work out.
12
and
days.
Came back to work at the visitor complex, and I'll be at the visitor complex in November. Will be 7 years.
Well, that's awesome. That's great. I've been here at the museum about 6 years, and
Okay.
Our good friend Bart Martindale, who become a great communicator out there. He and I showed up about the same time, and I said, I'm going to stay broke and work for this nonprofit, and you can go out there and work for Delaware North. But
I know he enjoys coming back here.
Yeah, that's great. Well, wanted to just let everybody know here what we got going here. We got this image of you at the Hubble, some working pictures here to set up with Steve here, that he not only is a great researcher, knows what he's talking about, you participated in a few things. Well, I'm thinking about RCA. Did you ever have to go to Findlay, Ohio?
No.
But I grew up in Findlay, and they had an RCA transistor plant there back in the 60s. I don't know if it ever crossed your path there.
We were located, I was at the, what was called the Vernon Valley Earth Station. That's where we control the RCA SATCOM spacecraft. They were built at what was called RCA Astroelectronics, and that was in Princeton, New Jersey, and Piscataway, New Jersey, which is where our headquarters were for our division of RCA. So all my communication for RCA was somewhere between one part of New Jersey or the other part of New Jersey, except when I had to go to the West Coast, when we had certain launches, and we had our other ground station, major control station at what's called South Mountain, California, very close to the Ojai area of California. So that's the only other places I went to with RCA.
And what town did you grow up in?
I grew up in a small town in Queens, New York called Rosedale.
Okay.
Right next to Kennedy Airport. We were right there on the landing pattern. You could easily see the planes going right over our heads.
My gosh. I had an apartment briefly in Long Island City, Queens, when I was working in my misspent youth in pursuing the news business there. I was actually working for Newsweek. And,
very good.
1980 and all that. So, well, here you are. Not many people get this close to the Hubble telescope, one of the most amazing things ever built by humans.
Well, what you're seeing in this picture on the left-hand side is Hubble. This is before its launch. It was launched on April 24th, 1990. The picture was taken from the top floor of the vertical processing facility, the VPF. This is where we would do testing. My job was electrical testing on Hubble, and my best memories of that mission were one, of course, on launch day, being inside launch control when we were going to be doing the Hubble rescue mission, or the repair mission, as some people call it, and that's Shuttle Mission 61. So these pictures right here, when we were working on Hubble, it was very, very important to keep any kind of foreign objects away from Hubble. So we had all these special rules. Make sure you're fully suited up. So you can see me there on the right. The only part of me that's visible are my glasses. You'll see tape around the gloves. There's tape around the boots. You could not get close. There's a mask over your face. Anything that could possibly contaminate this spacecraft. So we had to get very dressed. We had air showers, which is like a whole bunch of leaf blowers that would get rid of materials, and we had what are called tacking mats that you stood on. So there was a lot of, we had special paper. You couldn't take in a piece of paper like you have right here. We had special clean room paper that we had to use on Hubble. There'd be no flaking.
Wow. Well, it paid off. It's still going strong, well beyond its life expectancy. And, of course, now working in tandem with the Webb telescope is just an added bonus for astronomers out there. One other look at the past for you there. The on console, there's Mike Leinbach. Not sure. Is that...
Yeah, that is... Mike Leinbach, who was the shuttle launch director for that flight. The reason I chose this is this just happened to be the very, very first flight of the Space Shuttle Endeavour. And if you look to the picture to the left, you see the Intelsat spacecraft that we were trying to rescue. And if you do your counting right, you'll find out there are not two, but 3 astronauts outside. The only time in all of our history we had more than 2 people out. So it's very, very unusual. There was a problem connecting to the spacecraft. The only way to do it is to literally manhandle it. So the decision was made to do an extravehicular activity using a crew of 3. So it was planned while the mission was up there. It was not intentional.
Thebe, Thoet, and Akers out there, and our good friend, and you worked with him, I'm sure, Bruce Melnick.
That's right. You could be my boss. Yeah, that's right.
Bruce did not take the picture, though. He was working the robotic arm, I think he said at that time. Who's with Mike there?
I'm trying to...
That's not Charlie, is it?
No. Charlie
Thompson.
Charlie started about 3 weeks after I did. I started on July 5th of 1988, and she started, I want to say, the last week of July or the first week of August. So I've got about 3 weeks seniority on her down there.
All right. Well, that's a look at your past there. Now we're going to get into the Skylab story there, and I'm going to sit back, and you all sit back and enjoy how Steve's going to share this with you. Of course, I've looked at it through him there. He's going to show some slides that got a lot of print on it. You don't have to read everything. We're going to hit the highlights. But truly, 50 years ago, I don't think people appreciate this enough.
Yeah, Mark, one of the problems with Skylab is a timing thing. We just completed the Apollo program, going to the moon, landing on the moon. There's not many things to be competing with that. And here you are. You're 5 months after the last moon flight, Apollo 17. That launches in December 1972. You're leaving the moon for the last time. You just had 6 flights to the moon, all landing in different areas. And now you're going to be orbiting the Earth again. And it's going to be orbiting in a station that is just going to circle and do experiments. Well, compared to landing on the moon, that just does not capture the imagination. And then it's only 5 months after that. So the sense of timing could not have been worse. But Skylab, that I'm going to hope to show everyone in just the next half hour or so, it's a lot different. So of all the different programs, everybody remembers Project Mercury, John Glenn going into space. You remember Project Gemini, Ed White and the spacewalk, Apollo landing on the moon. You remember the first joint American-Russian mission, the Apollo-Soyuz test project. You remember the space shuttle. You remember Space Station. Somewhere in the middle there was Skylab. We had 3 flights, and in Skylab we spent just about 171 days in space. So the 3 flights together, a little bit less than 6 months, over a 2-year period, 1973 and 1974. And it came and went. And unfortunately, what we're going to try to do, or at least what I'm going to try to do over the next few minutes, is explain what the significance is of Skylab, and sadly, why we don't appreciate it. So as we continue on, and I'm going to ask everyone out there to just stay with us for a few minutes, and you're going to learn why Skylab was so important and how it is the basis for a lot of what we're trying to do today.
It is. Marty, we got any comments or questions for Steve gets wound up here?
No.
Okay, good. One comment I've got, Steve, is that not only you're correct in it coming so quickly after Apollo, and then the engineering people labeled the Skylab itself number 1, and the actual last crewed mission was number 4 to engineers, but the patch clearly says 3. So when you talk to space geeks about Skylab 2, we scratch our heads to which one do you mean?
Yeah.
The first with Pete Conrad that the engineers called 2, or the second one with artist
Alan Bean.
Alan Bean as the commander there. So just a side note there is kind of cursed, the whole thing. From
Yeah, it's unfortunate the launch of the laboratory, when the laboratory is essentially the 3rd stage of a Saturn rocket that's been modified, but the crew labeled it 1, 2, and 3 as the first crew flight, the second crew flight, and the 3rd crew flight. But if you look at documentation, sometimes you'll hear Skylab 4, and it's like there's only 3 flights. So the way I do it, Mark, to avoid any confusion, I'll say crew flight 1, crew flight 2, crew flight 3,
Yeah, that's good.
and the
Very
launch
good.
of the lab.
Yeah.
That's it. So
Very
that
good.
way, if you take a look at the symbols, the bottom symbol, which is the Skylab 3 flight, you'll see the number 3 right there in dark color. The 2, you can see the 2 underneath Leonardo da Vinci's image of the human body, and Skylab 1 in the upper left-hand corner. And you can see 1, because again, the crew labeled it as far as crew flight 1, crew flight 2, crew flight 3. And that's the way I like to do it.
All right, and you're going to learn a lot. So Steve, take it away.
All right.
Get you to the
Okay, so what is the Skylab program going to do? Well, we've been to the moon. We know from Project Mercury that people could live in space, and that's what we were trying to do. Can the human body withstand a whole day in space? And by the last of the 6 Mercury flights, yes, we can spend approximately 34 hours in space without a major effect. Good. Project Gemini, well, we're going to have to learn to go to the moon. We have to establish techniques. We have to be able to find another spacecraft. We have to be able to dock to it. We have to have a spacesuit you could wear outside of the spacecraft. So we had to learn how to do a spacewalk. Then Project Apollo had to learn to go to the moon. Everything was needed to do that. Well, if you're going to go anywhere further in space, you're going to have to spend a lot more time in space. The longest mission we had was Project Gemini's Gemini 7 flight, 14 days. You're not going to be able to learn a lot about space if all you go is for 14 days. And that's the record. That's what we have at this point. We want to learn more. To learn more, you've got to be there more. So we had 3 flights that are going to be scheduled. Crew 1, Crew 2, Crew 3. What are the goals of the program? Number 1, over the long periods of time, we have to be able to study the human body. Number 2, we want to be able to study the sun. We want to be able to study the earth. And so Skylab was meant to do those 3 things. Now, people have an idea how big the space station is, how big the space shuttle is. The reason I created this slide is so you get an idea of how big that space station is. And it takes up almost the entire bottom of the slide. Right in the middle of it, you have the space shuttle to scale. For many of you that have been to the Kennedy Space Center, you might have seen the Space Shuttle Atlantis. It's about 122 feet long. Well, the space station is about 360 feet long. On top of that, you can see Skylab. Skylab's about 99 feet long. So you can see how big Skylab is compared to the International Space Station. Now, what do we have on Skylab? Well, this is the way it was supposed to operate. If you look towards the right-hand side, you see two big solar panels. And you look to the left-hand side, you see a giant X. Those are additional panels. And they're attached to a thing called the Apollo telescope mount. That's a platform that was going to study the sun. In the far bottom left, you see the Apollo Command and Service Module that would take the crew up to the station. It would dock and place called a multiple docking adapter. We can connect two spacecraft to Skylab at the same time. Why did we want to do that? Well, if you're going to be sending a crew up there for months at a time, if something goes wrong, how are you going to rescue the crew? So we had two places where a capsule could connect. Then after that, we had an airlock, so you can go outside and do experiments on the outside, repair things on the outside. And finally, what's called the orbital workshop. The orbital workshop is the actual quarters, and that's what you're seeing right now. We had lots of things on Skylab. Since we were going to be up there for up to 3 months, we had a shower, kitchen, exercise equipment. What you're seeing in this diagram here, that we had everything you needed to spend a great deal of time, including a lot of experiments. In fact, there were 61 different research projects we did in space, and in the upcoming slides, you'll be able to take a look at some of them. Again, we're not going to go into great detail on these slides, but just to let you know what was available and what we were able to do on this station for not a day, not a week, not a month, but our last flight was 84 days, nearly 3 months in space.
I'd like to interject, there's also a very special airlock put in there for experiments that had that not been put in, the Skylab story would be a little different.
Oh, and we're going to be talking about that. Yeah, we
Steve
sure
will
will.
elaborate that.
Okay, so what were those research goals? Now, solar studies, studies of the sun. Now, the way this is shown, for those people, you'll see it at the very, very end, there is a summary of all the different experiments and what we learned on each of these different experiments. So the number of the experiment is all the way on the left, the title of the experiment in the middle, and then the location, where was it? So if you see OWS, that's the orbital workshop. That's the main body of Skylab. The ATM is the Apollo telescope mount. That was that part we showed you that intersects those solar arrays where the sun telescopes were. And then the X's, was it on the crew flight 1, crew flight 2, or crew flight 3? So you can see which experiment flew on what mission. The next group, 3 experiments on stellar astronomy. If you can go back, go back a slide. Yeah. That was the learning about the stars. Space physics. How do things work in space?
Micrometeoroid particle collection,
cosmic rays, things that are in space. 6 experiments there. Okay, moving right along. Earth resources. We have a great opportunity to study the Earth, not for a day, not for a week, but for months at a time. Taking first great images, and not by a remote satellite, by people actually making those observations themselves. And then finally, life science projects, learning about the human body. How do we exist in space for months at a time? And as you can see, that data absolutely crucial for operating the International Space Station. No Skylab, no data for the space station.
So many of these repeated also longer duration flights that
Exactly.
get a longer data collection.
Better baseline.
Yeah, absolutely.
Now, not only, again, this is more continuation of the life science experiments, but material sciences, manufacturing. If we're going to be in space to stay, we have to learn to operate in space. Anything that we have to do on Earth, eventually we're going to have to do something similar to it in space. How do things operate in space? Everything from crystal growth, as you can see, to forming spheres. So every one of these things had to be tested out and tried. Let's continue on.
Good. We got the...
All right, zero gravity system studies. Again, we know how the human body reacts for a couple of days. What about for months? The spacecraft environment itself. You don't have a spacecraft that's been in space for a day or two or a week, months at a time. How much is the spacecraft itself going to be changed? I know today, even on space station, the first elements of space station were launched in 1998. Those first elements are up there 25 years. Okay.
Absolutely.
How do you think they've degraded on the outside? Astronauts have done inspections. Well, this gives us a baseline for just a period of almost a year in space.
Keeping the command module in space, Steve.
Exactly.
We only did it for the longest duration was Apollo 17, I would guess, which would be 10 days maybe, matching what Apollo 7 orbited. But kind of some unknowns of when you're going to keep a command module up there for first 28 days and 56 and 84. I noticed they painted them white because they couldn't do the rotisserie thing to
Right.
So that in itself, I think, boy, showed that command module was
Well, one
amazing.
of the things, as you just brought up about the rotisserie mode, just in case people are wondering, as we sent spacecraft to the moon, we used to call it rotisserie, or I think the preferred term they liked was barbecue mode.
Okay.
As you slowly rotate, the idea is that you constantly try to keep the temperature very stable, like overcooking your steak if you just keep it in one place. So we would rotate the spacecraft in roll. Well, if you're connected to the space station, the Skylab station, that station is not going to be rotating. Well, you're stuck. You're going to be in one orientation, and you're going to be in that one orientation for months.
Yeah,
What do you need to do?
yeah, and they learned how to do that.
Yeah.
I think is a very valuable lesson. It's sort of never been repeated again.
Well, if you take a look right now, the International Space Station, it's routine now.
Right,
The,
routine.
the normal time we stay docked at the space station is 6 months, okay, which is double Skylab. If you look at Skylab, the first flight was about a month, 28 days. Second flight about 2 months. We doubled that to 59 days. Third flight, 84 days. Added another month. Really try to expand that envelope. Now we've had astronauts on board space station for over a year in a stretch.
All right, let's get Skylab off the ground. The amazing
Okay.
story of its launch. Tom Usiak's a friend of ours. He was photographing this as a young man in 1973. He saw the whole thing, and it all wasn't good, Steve.
Well, I said the Skylab program worked perfectly for just about a minute. Now, this is, it has been so popular ever since Ron Howard's movie Apollo 13 to say that, it was NASA's finest hour. And granted, bringing a crew back from space is an historic achievement, a magnificent achievement. Unfortunately, we don't really understand. I shouldn't say we don't really understand. We understand, but the people that are working it understood. But a lot of people don't realize what happened in Skylab. And this definitely has to be one of NASA's greatest moments. So let's proceed ahead
Good
and
point.
tell you.
And Tommy Usiak, you're going to enjoy the breakdown that Steve Agid is doing here for us about the timeline of when these events happened to Skylab.
Okay, now this shows you what Skylab looked like on the pad. You'll notice it doesn't have an escape system on it, and the reason is there's nobody on board. It is the last launch ever of a Saturn V moon rocket. That's May 14th, 1973. That third stage is the Skylab itself, and it's going to be launching into space. The following day, our first crew is supposed to go up to the station and connect to it to begin the Skylab program, but that's how it was supposed to be. Now, Skylab, when we got the shroud off it, looked like this. Now, what was supposed to happen is that square part that you see on the right is going to fold back on itself, make a right angle, and 4 large solar panels are going to come out of it. And that part worked just fine. On the left side and the right side, there are 2 solar panels, and they're supposed to come out as well. Let's move on. But here's what happened. We had a nominal liftoff, and just about a minute after the flight, there's a shield level surrounding the outside of the Skylab itself. As you're going up, you're picking up speed very quickly. The wind or the air got between the laboratory and this kind of a mylar shield around it, and it ripped the shield off. Now, what's the problem with that? That shield is going to keep the temperature on Skylab stable, and now it's not there. We don't know it's not there, but the telemetry is indicating that. Well, that just occurred pretty much when we hit Mach 1, the speed of sound, at about 25,000 feet. Now, a few seconds later, just about 3 seconds later, one of the arrays, array number 2, there's an indication on the ground that somehow it's unlatched. It started separating from the vehicle. That can't be right. Well, a few seconds after that, we're finding out there's a lot of vibration that we weren't expecting. Then we find that there's shocks being occurred. Finally, we get to maximum pressure a few seconds after that. The range safety is, the signal strength is starting to drop for the second stage on the range safety. There's a lot of little anomalies that are happening. So these are very, very hard to explain. The weather isn't perfect, so we can't see any of these things happening. And then finally, we find out from a telemetry that a few minutes after launch, solar array number 2 broke off the array. So we have a very serious problem, or I should say 2 very serious problems. One, the protective covering over Skylab is gone. So the sun is going to be heating up the inside of the structure. And number 2, our power system is not going to generate nearly the amount of power that we need. So here you have a brand new spacecraft that's going to be overheated and not on full power. What are you going to do about it? And we're only getting this indication from the telemetry. We can't really see what's happening. But on the ground, they're trying to piece together a story. Let's see what that story is.
Meanwhile, the crew was watching this thinking they're going to go the next day. Pete Conrad.
Right. And something is wrong. So here is that great challenge. I mean, Apollo 13 lasted over the period of about 6 days. Here's what we had to do on Skylab. Number 1, we had to review all that launch data. There was no eyewitnesses there. No one we could ask what's really happening on Skylab. Number 2, we had to determine what do we think the cause of the problem is. Number 3, well, if this truly is the cause, what's the impact of that problem? What do we have to do? Come up with ideas. Number 4, evaluate and determine what's the solution. Now that we think we know what the problem is, what are we going to do about it? We have all these people arguing, let's do this, let's do that. Well, one of the solutions has to be checked, and one of them is going to have to be, all right, that's the one we're going to use. You have to make that decision. All right, now you decided to do that, you have to find out, do you have the hardware available? Is it available that we can use right now? Can we obtain the hardware right now? Can we transport it to the Kennedy Space Center? Can we write all the procedures to something that we're not really sure is really wrong yet? Then train the crew. Then train the mission control team. Then you have to load all this stuff on the spacecraft. You have to do the launch. You have to do the countdown and launch. And you have to do all of this in 10 days.
There you go. Truly an amazing accomplishment, and showed Johnson Space Center particularly at their best. And I've talked to some people involved in this. Don Arabian was one.
Don Arabian, yeah.
Yeah, they called him Mad Don Arabian. And, your eyes lit up there.
Oh, Don Arabian, no guy, yeah.
He bragged about the bonus check he got for helping. One of the last things he did there on there. What is this? We're going to see what this looks like right here.
Okay, so let's take a look. We can blow that up a little bit.
Sure can.
These are examples of those problems. Okay, the data shows, and again, I want to caution all the viewers, on Apollo 13, you could ask the crew, what about this and what about that? And they're right there and they'll tell you. We're trying to look at telemetry information. We think if we see this and this, we think that what happened was this. We don't know that for sure, but that's what we're going in with, because that would be what it indicates. We're not going to know for sure till the crew is there. Now, why did I say 10 days? Well, 10 days is not a number plucked out of the air. The spacecraft, or I should say the spacecraft is heating up. The temperature is getting warmer and warmer. We'll see how much that is in just a few minutes. But the data shows that that shield was indeed ripped off. Okay, the temperature is starting to go up. The inside temperature reaches 126 degrees. So what do we have to do? Well, you got to come up with some kind of, outside covering, some kind of umbrella that you could put over this thing to shield the spacecraft, to somehow stop the sun from getting to the spacecraft itself. But the problem is this, and you alluded to it just a few minutes ago. We had a scientific airlock, a very small airlock, and we'll show you that in just a few minutes. We could actually do experiments from the inside. It was a very small airlock, push something to the outside, and it would be exposed to space. And you could drag it back in again, but it was a very small airlock. Well, this big area of Skylab, and Skylab's pretty big, it's about 21.5 feet across. You have to deploy some kind of big shield over this thing and fit it into this small little canister, this small little container that's about 1 foot by 1 foot. So figure out how to do that. So let's go back to the slide. Go back one and enlarge again.
Go back
Other way. There we go. All right, so kind of come up with some kind of cover, but it has to be small enough to fit into the command module so you can launch it with the crew, and it also has to be small enough to fit into this little baby airlock and still be big enough to cover the outside of Skylab. Not to worry, Mark, you got 10 days to figure this out.
Right.
All right,
Okay.
That's number one. Number two, the array. The solar array that's giving us power is not giving us power. Well, looks like number two, the solar array number two, is gone, period. Solar array number one seems to be giving us an incredible small amount of power. Maybe it's stuck. Well, if it's stuck, how do you unstick it? Well, we really don't know. So the engineering team is going to be working on this. Again, you got 10 days. Remember, the food's on board Skylab. It's not going to like that 126-degree temperature.
How about the film on board?
The film,
for the solar
everything.
telescope.
Exactly. Everything's on board. You can't turn on anything to make things cool because you need power, and we don't have the power that we need. One of the big debates is we can fix this problem very quickly. All you got to do is turn Skylab away from the sun. There you go.
Right.
That would make the temperature drop. It would also give you no power. No power, no telemetry. So you just imagine the power people want to keep that on the sun so we can get data and we can see what we're doing. The thermal people worried about the temperature. No, get us away from the sun so the spacecraft will get cooler so we can actually preserve the food, so the debates are going on. So what do? If you look, let's go back again, Ted. Let's go back to where we were. Because to show you how motivated the crew is,
I'll go back
one and enlarge. Yeah. Go back to where we were. Okay. There we go.
Yeah.
So to meet that timeline, to do all those things in the 10 days, the engineering team has to work straight for 30 hours. You get an 8-hour break, come back for another 30 hours, and do that day after day in order to make this deadline.
That's crazy, but they did it. That's the dedication
Yeah, that's
of
it.
people today with the here's how we can, not how we can't
Exactly.
attitude. Yeah, Marty. Oh, we got our Dutch friends here. Jacques and Rob are here. So I hope they're enjoying Stay Curious. We see them after the show here. They're here for the launch of Psyche today, filling up the coast. Going to go off tomorrow morning, we hope, on there. Yes, this is quite an amazing dilemma that Skylab's in. Of course, it's orbiting the Earth, Steve, so it is in darkness for 45 minutes, but it's not getting any energy. So that 45 minutes where it's getting a trickle of energy so we can find out what's going on is heating it up. So here's the solution.
Sorry. So we have across the street, just across the street from the Johnson Space Center, they're manufacturing this blanket. This is kind of a blanket. The best way I can explain it is make believe you have an umbrella. And you're going to push the umbrella so you push it all away so it's curving outward. And then you're going to push a button and that is going to come back flat again, like you could actually use it. So invert the umbrella. So what they're going to do is they're going to make this device, telescope it out of this small airlock, and then deploy it so it covers the outside of Skylab. So this work on that shield is going to occur just across the street from the Johnson Space Center.
Here they are working on this.
Working on it, yeah.
Describe the material. You might own some in your
Yeah.
space cave there. It's a little, usually get a credit card sized information
Right,
about
it's kind of-
Skylab, and has a little patch of it on it.
And there you go. It's a top layer of Mylar. Mylar you can get at the Space Center. They cover it. It's I think they use them in football stadiums and such. It's that, keeps you nice and
Yeah,
heated
right,
very
yeah,
light, like
yeah.
that gold Mylar. Yeah.
Yeah,
All right,
keep you warm
moving
at
on.
night. So quite an engineering feat here. You got a seamstress there, Eileen
Right.
Baker.
Mm-hmm.
It was few people actually had hands on it, but probably 100 engineers come up with the idea there.
Okay, now there's a picture I promised you. On the upper right, you can see this airlock. Okay, you can see it's not very big, and on the lower left, you can see where it's located on Skylab. Just so happened to be located right where we would want it to be. So that square little airlock, again, it's 22 by 24 foot sun shield. So that's how big that upside down umbrella is. But the airlock itself is only a foot by a foot. So again, we're talking about something about that size, and you're going to have to put this umbrella in it and open it up, and that umbrella has to be 22 by 24 feet of material. It'll unfold and cover that whole side of Skylab.
First we had to get the astronauts up there.
Now, we did problem number 2. Okay, now, even if we brought the temperature down, that'd be wonderful. Not good enough, because now, yes, the temperature's great, but that would be like the day after a hurricane in Florida. The temperature's a whole lot better, but you still don't have power. So you're still not good enough. So what we need to do is we have to assume that that array is stuck. So if it is stuck, how are you going to unstick it, knowing that I don't have a picture and say, that's the problem? So what they did in the tank here, this is one of my absolute favorite Skylab stories. There's a fellow named Cliff Bosch. Okay, he is not a spacecraft engineer. He works for the A.B. Chance Company. It's a little company in Centralia, Missouri. And he no doubt turned on the news that morning and heard about the problems they're having with Skylab. He's going to go to work, have a normal work day, come back home. No connection with the space program at all. All of a sudden, there's a phone call. And that phone call, it goes to the A.B. Chance Company. Now, why they pick A.B. Chance? A.B. Chance makes equipment for power line problems. People that work at very big heights, they have to install power lines, they have to be able to cut lines, and it's extreme conditions using very unusual equipment. And they ask Cliff Bosch, have you heard about Skylab? Yeah, I'm sure. And they ask him, can you bring all the types of equipment you have to work on power lines and cables and cutting things and such, and bring them out to the airport? Okay. Is there any paperwork? No paperwork, no charge, no nothing. But get them out there. There's going to be a plane there. Okay. NASA then gets him to fly, and he ends up going to Huntsville, Alabama. So you woke up in the morning, having your cup of coffee, and by evening, you're briefing the crew on the equipment you have.
Wow.
And who's he briefing? Story Musgrave and Rusty Schweikert, the 2 astronauts, and they're showing and reviewing all the equipment that Cliff brought them, saying, that's what we want to use, this very long thing that looks like a giant scissors. That's what we think is going to cut through things. And it's funny because there's a wonderful documentary on it. It talks about telling, this man, Cliff Bosch, telling his wife, you better bring a suitcase with a lot of clothes for me and bring it to the airport. So again, what began that day as a normal work day at a normal small company, you end up that day talking to the astronauts that are going to have to try to repair Skylab, and you are right in the middle of it. Then he has to train them on how to use this equipment.
And here they are in the underwater training session. There.
Exactly.
Story Musgrave and Rusty Schweikert. Huh?
That's correct.
Okay, they were Apollo era astronauts.
That's right.
And,
Well, Story flew on shuttle, and Rusty Schweikert on Apollo 9. Okay, so they're supposed to launch the next day, which would be May 15th. Well, there we are, 10 days later, May 25th. 9 o'clock in the morning, our first crew, astronauts Conrad, Kerwin, and Weitz, they launch here from the Kennedy Space Center. And they're going to be going up to Skylab. Now, they have a camera on board. They're going to show the engineers on the ground exactly what's wrong with Skylab. And unfortunately, we don't have a video for this, but that orange section you see right there on the upper right, that's the skin of the spacecraft. That's supposed to be covered. Well, it's not. When they do the look around, they say, yes, solar array panel number 2 is completely gone, but if you have really good eyes, if you look at the words NASA, or the NASA logo in the upper right, you'll notice that if you trace that blue square all the way down, you see it bends out a little bit towards the NASA. It's partially deployed. It was entangled in bands of wiring, so it couldn't fully deploy out. Okay, so what we're going to try to do is cut it. Okay, so these are better pictures, and you can see that array on the lower right. You can see it's partially out. You can see the top section there partially out. The view on the left-hand side is a view looking back. This is taken by the crew as they're flying around doing an inspection, and you can see at the top that gold section, that's the skin of the spacecraft, and it is starting to degrade pretty good. It's only been in space 10 days. It's not supposed to see the sun, and it's been staring at it for 10 days. Okay.
You got
So,
that little thing there. So
all right, let's move on. Now, this would be a video taken from the crew on the inside. Unfortunately, you can't see it, but right above where my head is, and there we go, in that direction, right there. There we go, right there. They just push that umbrella out, and it will unfold to protect that side of Skylab.
Yeah, that's the reddish or rosy color
right,
there.
Exactly.
Is the fix coming out.
Okay, coming out of the airlock.
Get on YouTube and watch that
Yeah.
deploy there. Well, we don't have that capability here on our limited thing. Yeah,
Okay.
then you've got the
And
crew.
the crew, in a tribute to when they entered the lab, once they got the temperature stabilized, they were able to enter. Once they got that array deployed, well, now you have power, way more power than you had, and the temperature slowly starting to drop. If you look at the early days of the mission, you can see they're always wearing shorts because the temperature was quite toasty. And later on, they got into their full brown suits. And for the folks at home, they do have one of the Skylab suits right here in the museum. You can see what those orange suits look like.
Yeah, that's the one that the Cripp used, Bob Crippen in
for
the
the,
SMET.
SMET test, the medical
Skylab
experiment test.
medical experiment, altitude chamber test there.
Okay, let's move on. Okay, this was a picture that was taken by the crew, and now if you take a look at the bottom section, you see that big square area protecting Skylab. This picture was a departure picture. This is after they spent their month in space, or just about a month in space. Remember, they launched on the 25th. This is June 22nd. They're leaving Skylab. So you can see that square array on the bottom right there.
Yep.
on the bottom.
Yep.
And that array is out. There we go. There we go. And that shield is covering it. So it's way better than it was after the first flight. Now that we know what we're dealing with, Skylab 2 will be able to make even more improvements. Let's go on. So what did we learn from this first flight? Most important thing we want to stress is that we were able to take a mission. Again, if they couldn't come up with this in the 10 days, the whole program would be gone. That was it. That was the end of Skylab. We did have a backup Skylab. That backup Skylab is in the Air and Space Museum right now. But again, what did we need to know? How long will it take? And again, the Saturn V, the Apollo 19 Saturn V is the one that you see displayed there at the Kennedy Space Center Visitor Complex. But what we wanted to show is we could make changes. Human beings out there can do things. And we were able to surmount all these difficulties and save the entire Skylab program. We demonstrated that people could spend that long in space, 28 days. We found out there was no significant degradation to the human body at that time. We had to learn, you mentioned it slightly before, that the command and service module could stay connected for 28 days. On space station now, we're routinely having those modules, the equivalent modules, up there for 6 months. But learning how to do that, this is where we learn that. We learn these things in Skylab, especially on this first flight.
It was a great first flight. You could not without its moments of unfurling that solar panel Pete Conrad cutting the cable and it flung him across
Yeah,
the
absolutely.
space there, kind of dangerous. But they're willing to take that risk to save this station, like Steve's pointing out here. Steve, Agid, we're so glad that you're here sharing this. We're going to go through the last two missions here and accomplish a lot of science, solar astronomy that was pioneered here 50 years ago is laying the bedrock for our active solar cycle today.
Okay, here we have our second crew. Alan Bean is on this crew. Alan Bean was on Apollo 12, second moon landing with Pete Conrad. Now, the Leonardo da Vinci Vitruvian Man is the center, and it shows half the patch to the left is on the sun, half the patch to the right is on the Earth. So that's the symbolism, and you can see Skylab 2 there at the bottom. Mm-hmm. Now we launch, we get to the station. Of course, now we know what to expect, so let's make some improvements here.
The launch is on the famous milk stool.
That's right, yep.
To raise the Saturn S1B up to the level of the White Room.
Now, the reason we did that, the Saturn 1B for Apollo 7, for example, was on pad 34. Well, pad 34 is being dismantled. Well, how do you use a tower that's built for a rocket that's 363 feet, and you're launching a rocket that's only 224 feet? Well, what we do is we put an additional platform up there so all the little swing arms will match where they need to go.
Yeah, that was an amazing, brilliant idea there.
Okay, now, so Skylab, the first crew flight, had to find out what was wrong with Skylab. Second crew flight, we know what we're getting into. Well, that's great. So we launch, get to the get ready to go to the station itself, and what do we find out? Well, we find out just about 8.5 hours into the flight. Again, day one, you just got started, and the thrusters on the side of the service module. Again, the craft is in the triangular section there. The service module, one of the thruster quads is having a problem. One of the valves is leaking. Well, that's your fuel that makes you steer the vehicle. Well, that's not good. Well, but the mission rules say that's okay. You can still proceed with the mission. 5 days later, a second quad is starting to have problems. Well, now you really got a problem because you need this to be able to steer Skylab when it starts coming down. You want the crew to return safely. So now we do have a problem. And remember, this flight is supposed to be 2 months long, and you're 5 days in. And it's a question of whether you can come back safely. So what are we going to do? Well, we had a question years before. Remember, we talked a few minutes ago about the multiple docking adapter. You could connect two spacecraft to Skylab at the same time. And if we can go back to this, if we could blow up the slide again. In 1971, and again, that was about 2.5 years ago, crew members Jack Lousma, and who was actually on this flight, Alan Bean, they went to the Rockwell facility where they made the spacecraft and thought about what modifications could we do to possibly have a rescue just in case it's necessary. You know, just in case. You know, you could have that third mission, 3 months in space, you're happy, and you turn on your spacecraft, which you haven't used for 3 months, and it's not working. How are you going to get back? Well, you have to be able to send another spacecraft to dock and bring you home. Well, that's fine, but the spacecraft normally handles 3 people, and you got 3 on Skylab. The Apollo spacecraft doesn't handle 6; it handles 3. How are you going to do that? So come up with a design so you could launch with a crew of 2, not 3, and take the other 3 home. So fit 5, and that's what you're looking at right there. Astronauts Vance Brand and Don Linder being trained. And you can see on the lower left what the Apollo spacecraft, this Command Service Module 119, was going to look like. 3 astronauts, and underneath them, squeezed in, the other 2. So in other words, 2 astronauts, Lind and Brand, would go up to rescue the crew. The other ones that are on station right now, Bean, Garriott, and Lousma, 2 of them would go underneath the seats, 1 to the side, and that spacecraft would actually be able to handle 5 people in the event of an emergency. So we're doing that as well, and we'll have a great story about that in just a few minutes.
Is that a real patch that was created for that? Or
I
did you
don't know if
create
it's
that?
real or not. No, I certainly didn't create it,
Okay.
but that was I don't know whether that was a tentative design, but Brandon, Linda, that was, the idea is that they were selected to do this.
Did you ever have a chance to talk to Vance Brand
Neither
about
one.
this?
Vance Brand and I, oddly enough, we have the same birthday.
Oh, do you?
Yeah. Vance Brand,
When's that?
and that was May 9th.
May 9th.
Yeah,
All right.
so-
Cool.
All
Well,
right.
he's a good. He's 90-some years old, and
And he flew on the Apollo Soyuz mission, which at this time was only about 2 years in the future.
right.
Okay.
That looks like 14 out of the Space
That's
Center.
Apollo 14 at the Space Center, yeah.
All right. Kitty Hawk.
Kitty Hawk.
Kitty Hawk.
All right, so it turns out they didn't need to return, and what they did is they replaced that first umbrella with a much better boom shield that they put on Skylab. So they improved the shield that was put on by the first crew, and what you see on the bottom is how much time they projected to use on all these different experiments pre-flight. And as you look to the bottom right, turns out we were able to spend a lot more time doing a lot more science than we thought we were going to be able to do. So that was, very worthwhile to see that we were able to do more on that second flight than we expected to be able to do.
You, of course, Jack Lawson has been a favorite out to Kennedy Visitors Complex. Sure, you've chatted with him a few
Yep.
times. Did you ask him about the anomalies on the thrusters? Those were hypergolic fuels, by the way.
Right, yeah.
That, no, didn't need an igniter. They just touch
Right,
each other
exactly.
and blow
Very
up.
caustic.
Yeah.
No, what I talked to Jack about when I spoke to him is I can't imagine there's any listener that has not heard Houston, we have a problem.
Right.
Houston was Jack Lausma. Jack Lausma was a capsule communicator that night.
That's exactly right.
So I talked to him mostly about the Apollo 13 activities that he had.
Oh, Marty Winkle, chairman of the Grumman reunions they had Jack at almost all of them there.
Okay.
And really a great guy, isn't he, Marty? Jack Lausma. Hope he's doing well and staying healthy. Do you know if he's going to be scheduled this cycle out there?
I haven't seen anything past the next month. As
Okay.
far as I've seen, it's the next month.
All right, good.
Okay, moving.
Coming out today, the new list there. Okay.
Okay.
All right. Well, we got the
All
third
right.
crew.
We got the third crew.
All
We could,
rookies.
we could zoom in on that. Remember I told you the very first slide, we're going to study the Earth, we're going to study the Sun, we're going to study the human body. If that is what Skylab 3 wanted to do. If you look at that patch, you see the big number 3. If you look at the top part of the 3, you see a tree representing the Earth. You'd see the orbit representing physics, and you see the human body out to the left-hand side. So that is this third flight. We want to spend 84 days in space. Finish up this mission. So let's move on. So what did we do on here? Again, after spending, at this point, many months in space, a lot of equipment is not working anymore. So we took up a lot of new systems, changing coolant loops, doing troubleshooting, repairing some instruments like the multispectral scanner. There was a comet that was going to be appearing, the comet Kohoutek, and it was the first observations ever by a crew in space of an astronomical event, a comet astronomical event.
Comet
And
Kohoutek.
that was the first time that we had a crew in space
That's wild.
for that long, a period of nearly
Right.
3 months. Okay.
Yes.
So, the Skylab program, if we had to look at a very quick synopsis, for those that are interested, at the very, very bottom, if you go on the internet and you just enter NASA SP, that's Special Presentations 4011. So it's NASA space SP-4011. You'll get the results of every one of the Skylab experiments, what the experiment was and what the results are. So I'm just going to give you a little bit of a summary of what we learned about solar flares. One of the things we learned was they occur much more often than expected. And coronal holes were a major source of the solar wind. Didn't know that before. Earth resources. We identified mineral deposits in areas that we didn't realize they were. When you have a spacecraft with people aboard for months at a time, remote sensing is just being developed now. Life sciences. Here we learned that humans can actually stay longer in space. Again, 3 months. And while space travel affects the cardiovascular system, using exercise to combat that. On station right now, on the space station, astronauts must exercise at least 2 hours a day to try to combat that. Material science like crystal growth, something routinely done on the space station right now, initially done on Skylab. Let's proceed on.
Okay.
Now, one of the things we want to do, we left Skylab in 1974. Well, Skylab, as far as we know at that time, is in a stable enough orbit that it'll last probably until around 1983. That's no problem because we're going to send the space shuttle up to connect to it, add on to it, make it even bigger. Sounds like a great idea. And after all, the space shuttle is going to be launched in 1979. Well, things didn't work out like that. The space shuttle was not launched in 1979, nor 1980. So, we have another problem. If we can zoom in on the slide again.
Yeah, cool.
As time went on, the solar activity was much more active. The sun was much more active than we thought it was going to be. So hitting those big arrays is going to decay that orbit. So the activity was about twice as much as we expected. So Skylab's orbit is going to start to decay. We thought it's going to last till 1983. Well, now it's 1982. That's not bad, but we're going to launch the shuttle in 1979. Well, then it found out it's going to decay in 1980. So on one hand, Skylab's coming closer and closer to the ground. On the other hand, the shuttle that's launching in 1979 looks like it's going to be 1980. Ooh, now it's really close. And then it's going to be 1981. Finally, what happens is we find out that Skylab is going to decay. It finally happened on July 11th, 1979. So we were going to connect to it. You can see the 4 pictures at the top of the screen. We were actually potentially thinking of connecting an external tank to it and use the inside of the tank for more living area. So there were all these great ideas. One of the first space shuttle missions would be to reactivate Skylab and use it, but it was not to happen.
That was going to be STS-3, in fact, with Fred Hayes as the commander, and he was actually training for that. I think Vance Brand was involved in it too.
We had, like I said, and Fred got to do the approach and landing test, but we never got the opportunity to go to Skylab.
Right, but it's such a, like Steve has said, just such a quick 4 years, and then this thing, from its launch in 73 and 79 is gone. That's 6 years. Sure did captivate the world though when it came down, Steve.
That's true. Let's move on.
There's all kinds of things going on there.
Okay, so for those of you who'd like to see Skylab, there's 2 ways to do that. One, you can go to Alice Springs, Australia, and try to pick up a couple of pieces from the ground. The much preferred one is to go to the National Air and Space Museum in Washington, D.C. That backup of Skylab is there, and you can actually walk through it. And the picture on the right will give you an idea of what you'd be able to see. You can see how big the Skylab was. Okay, we can move on.
The Johnson Space Center also has a nice replica there of it there. And what gets me is the graded floors there that you're looking through. And
now, that graded floor, if you could look at it, it's kind of like little triangles. We had booties the astronauts had with triangles. So you'd step into the floor grid and twist your foot, and that would lock you in place.
Yeah, don't think that worked out too good.
No.
They get these engineering ideas, but so that's a working model when you go to the Smithsonian. They could have launched that. Any idea why they? Oh, there was no Saturn V available. For one.
So that was again the idea is that what would they have done and what changes would they make, and again you really didn't know what you were dealing with. Okay, now remember we talked about that rescue mission.
Yes.
Well, if you go to the Kennedy Space Center, as soon as you go to the Saturn V facility, you come out of the second movie. Right in front of you is Command Service Module 119. That was the one that was modified to capture the crew in the event that we had to go to Skylab and bring the Skylab crew number 2 back to Earth.
I was standing beside that Saturday watching you do a tour there. And then you have another replica that people can look inside.
Yeah, you can go
over to.
Yeah.
Or is this? That's it.
No, you
right?
can. That's the real one. There's a little staircase just off
Yeah,
the left-hand
okay.
side. You
Yeah,
can look in.
got
You have
you.
a replica of the capsule, and that's at the other end of the rocket.
Right. That's right there. The real deal there.
Real deal. Yeah.
And then the real lunar module.
Real lunar module.
LM number 9
Mm-hmm.
is sitting at the end of this thing. So Cliff Watson, he's our Pomona, Australia buddy down there.
Great.
Enjoying brekkie, and he's looking for the donation button on our YouTube, and they don't put it up there, Cliff, until the next day on the rerun of this. If you look at yesterday's show, it has a donation button on it. We don't know why, but thank you for thinking about us and our nonprofit, Cliff. We've got Cynthia Rossi's watching there. You may know her. She goes out there and gets autographs.
Oh, okay.
Doug Forrest is in Los Angeles. Dave Stangy and granddaughter are watching. She's our youngest watcher, about 9 months old, I guess, up there in Michigan. Robert Law is enjoying a cocktail in Dundee, Scotland. And I know you appreciate the knowledge of Steve Agid here. You may have met Robert. He comes out to the Space Center. We're looking forward to seeing him maybe in February. Tammy Miller, you know Tammy gets autographs out there. Gary Gerald, he's our Vidalia onion and peanut farmer. He's watching in Collins, Georgia out
That's
there.
great.
Carlton Bailey, CB's pestered you a few times for autographs out there, our launch photographer. Carlton's got remotes out there, so we're looking forward to your pictures of the Psyche Falcon Heavy launch tomorrow. Larry Pushkar is also a Michigander, as is Bill Whiting. And the astronaut files is John Borelli, Marty, our friend in New York. John Borelli, we had him on the show. He's the astronaut files. Maggie's watching. That any kin of yours? Maggie? And Astrogel.
Oh, okay.
Can't get too much Astrogel out there. So thank you all for watching Stay Curious. This show with Steve here should have put us up there as I'm giving the countdown there. Steve, we got a beautiful other comparison shot here.
Okay. Yeah, I did this on my own here. It's a nice picture of the space station on orbit. And what I did is I sized the departure of the first Skylab mission and actually scaled it so you see exactly what Skylab would have looked like if space station and Skylab were in orbit together.
Wow.
So there it is. That's a sized shot. You get an idea of how big space station is that we have right now, how big Skylab is. Again, the station's 357 feet, Skylab about 99 feet. So you can see, how big the solar panels are on Skylab compared to what we had on station.
The windmill is for the solar telescope.
The Apollo telescope mount. Those are the panels that came out correctly.
Yeah. And I'm sure they siphoned off energy of those to supplement the other one.
But again, it wasn't enough.
Very successful mission. Museum friend Ed Gibson is alive from the 50 years. You got Jack Lausma.
Yep.
And you also have on Skylab 1 is living.
Let's see, not the Skylab.
Conrad White
and Kerwin.
Kerwin, yeah, Joe Kerwin.
Okay.
One from each mission is alive to talk about it 50 years later. We'll be losing them soon. We'd love to get any of them on here. Ed Gibson, by the way, has written a couple interesting fiction books about space on there. So, Steve, and wrap it up for us.
Yeah, this is pretty much our wrap up. So you're looking at Skylab, and the Skylab program actually demonstrated to the world the value of humans in space. If we just launched it, just like Hubble, the same thing. Hubble had a problem, it took people to fix it. Well, it set up the foundation for future research in Earth and space sciences, material sciences, human health. And today, if we can blow that up again.
No.
Yeah. Today, that research that's conducted on the International Space Station with those 6-month standard missions with international crews, we don't know where the future benefits are going to come from on these long-duration flights. But we can tell you one thing. For these long-duration missions and the things we learned, you don't know where it's going, but we can tell you for a fact, Skylab is where it began.
Absolutely. And be proud of that and America's first space station and learn so much about it. And How many years now has the International Space Station been continuously occupied, Steve?
Yeah, the space station, the International Space Station, has been occupied since November 2nd of the year 2000, which comes out to 8,379 straight days.
Well, you got that down to the day.
I do that every
Celebrating
day.
23 years coming
Yeah.
up here in 2 weeks, and we'll be celebrating it on Stay Curious. Here is we honor a lot our people in space. We've got 7 on the space station and 3 on the Tiangong Chinese space station.
Yeah, you have
orbiting.
right now at the present time got 2 Americans, 3 Russians, 1 from the nation of Denmark for the European Space Agency, 1 from the nation of Japan.
That's right. 2 women orbiting the Earth. If you get an update as we go out here, I haven't looked at the leak that was going on the Naku Science Lab.
Right, on the Russian side, no,
Yeah.
I have not gotten an update on that. There had been, leaks on the Russian side before
Yeah.
recently, and that delayed one of our astronauts that is supposed to come back on a 6-month flight, went for a year. He just recently returned.
Steve brought a beautiful patch here. Wanted to show off there. It's got green in it. That's why we got the green screen.
And it's a patch made by one of the great designers out here. It's a little symbol of all the
Tim
different...
Gagnon?
Yeah, Tim
Of
Gagnon.
course. Tim's a friend of our
Yeah,
museum.
it has all 3 of the missions symbolized. It shows the lab itself. It has the backup crews there. And so, I mean, it's just one very, very pretty large patch that symbolizes the whole program. And Tim's just outstanding.
Oh,
for
he
these
certainly
tremendous
is. We
things.
appreciate his friendship at the American Space Museum. He's designed our Shuttle Fest shield that we'll be showing you a lot here for our April event coming up, and we'll be getting you involved in Shuttle Fest and other things here at the
Looking
museum.
forward to it.
What before we let you go, big mission tomorrow. What's the excitement from the fans in the stands at the Kennedy Space Center about the Psyche spacecraft going to a hard rock astronaut? Heavy metal
Yeah, there you
asteroid.
go. Well, the Psyche mission is going to a place called Psyche, or it's actually called 16 Psyche. It is a asteroids in orbit between Mars and Jupiter, and this is what we believe most of these rocks are made not straight metal. This one we believe is iron and let's see, what was it?
Nickel.
Nickel.
Yeah,
Iron nickel.
a lot of nickel out there in
And
that
the idea
space.
is that we've got a bunch of experiments on board. We're launching tomorrow. It won't get there until 2029. It's going to orbit this small asteroid. It's about 150
We have
miles.
6 years to wait after
Right.
Mars launch. Huh?
Exactly. Till you get there. Then you're going to orbit for 2 years. But in those 2 years, the amount of experiments we have on board to detect what it's like on the inside. Now, why that's important? Most of the asteroids you see are made out of stony ones, not straight metal. Well, how do we know the straight metal, and how do we know the characteristics? Well, the experiments will tell us that. And that would tell us what we believe the inside of the Earth is like. The inside of a lot of these different planets are those heavy materials. So the Psyche mission, that's why we're going to that as opposed to another asteroid. And the spacecraft is very large with those arrays extended. And it's, like I said, it's going to use the planet Mars to assist it to getting there. And again, a lot of people are discouraged when they say, well, wait a minute, that thing's going to take 6 years to get there, and then it's going to orbit for 2 years. That's a long mission. Well, just about a week or 2 ago, OSIRIS-REx returned. Very, very long mission with a piece of
An asteroid.
the asteroid Bennu.
Yeah.
And again, Bennu and 16 Psyche are very, very different types. But, you're going to have a briefing, I think, within the next 2 weeks or so to find out what we learned from that mission. And it's great because it was returned with the material inside. The material will be exposed in a vacuum and such. So they'll be able to see exactly what this material is like, make a great discovery. And we expect that in about 2 weeks to have the first science briefing on that, to learn more about the universe that we're a part of.
Absolutely. Bringing back pieces of alien worlds to Earth is where it's at now. Astrobiology, you're looking for new places for kids to go to college. Space is full of now the disciplines that were once restricted to Earth. Astrobiology, planet geology, and so forth and so on. So thank you, Steve Agid, for a wonderful conversation here. We're glad that you're friends of ours here at the museum. We always enjoy seeing you out at the Space Center. We being Marty Winkle, my co-producer here, we're out there, try to be out there every week. I get a little bit busy, but Marty's fully retired, and we can't say enough about him wanting to volunteer and help us with Stay Curious here. So, Marty, anything to clean up over there? Certainly learned a lot about Skylab today, and we know our Stay Curious watchers did too.
Just a lot of good comments about today's show. A lot of people thanking Steve.
All right. Well, he's a warehouse of shows. We'll have him polish up another one here on one of his expertise there. But 50 years of Skylab. Think about that out there. And, we thought we'd have the 2001 space station wheeling around after this one and so forth. But, hey, you live long enough, you're going to see wonders that you never thought you'd see anyway. So, once again, thank you, Steve. Agid, for a great program today. We can't wait to have you back on Stay Curious. Tomorrow we're going to look at Future Friday. We'll be looking at the Psyche launch. You can't miss an opportunity to see two Falcon Heavy boosters or Falcon 9 boosters come back side by side on the Space Coast. 10 something in the morning, Marty, for those of you asking. 10, what is it?
I want to say, I think it's 19. I think it's 10:19.
10:19.
1 second window, so it's going or it's not going.
There you go. Only the 4th day launch in about the last 20.
Yeah.
So all those noisy rockets keeping up at night we'll deal with it, won't we, Steve?
Oh, yeah.
All right. Well, thank you, everybody, for enjoying this edition of Stay Curious. I'm Mark Marquette saying I can't wait to see you again to bridge the space between us.